And welcome, function folks. Huge day today, big day. Lesson 3.14. It is the pi lesson. 3.14, or for some of you that wish you were rather back in grade 11, happy lesson 180 degrees. And someone can explain that to some of you guys out there, or how this is the pi lesson or 180-degree lesson. I hope you got that. Anyway, easy peasy 3-minute review, but we'll see the stuff that we get into today is actually a little bit of review and a lot new. So 5 pi over 3 is, remember, pi over 3 is what we would think of as the 60 degrees, but we think of that as 3 pi over 3, then 4 is in this quadrant, 5 pi over 3 is almost all the way around, right? 2 pi all the way around is 6 pi over 3, so we are pi over 3 less than that, right? And there's the angle theta. And you give 3 angles coterminal with theta. Well, the first one might be the negative, you'd say, negative pi over 3. And then we know that, it's the spin idea, right? 1 spin plus 5 pi over 3. So 1 spin plus 5 pi over 3. Right? Go once around plus 5 pi over 3. I'm actually going to erase that and go the other way, okay? And write it as 5 pi over 3 plus a spin, which is, we could calculate that, I suppose. Get that out of the way. Here, what is that calculated? Well, common denominator is 6 pi over 3. That's 11 pi over 3. And then another 3 angles. Yeah, we got to do one more. Would be 5 pi over 3 plus 2 spins, right? Plus 2 spins. So 2 pi times 2 is 4 pi, which is just another 6 pi, and I could write that down. It's another 6 pi to that is 17 pi over 3. And this is maybe new. Give an expression for all angles that are coterminal with theta. And then coterminal are 5 pi over 3 plus any number of spins, right? Well, a spin is 2 pi, and how do we get it to be any number of spins? Well, we multiply by n, where n has to be an integer, right? And notice that if n is 0, we get our principal solution. Principal solution is, remember, between 0 and 360. We like that one to be the principal solution, or principal angle, I guess. And then this is any number of spins. For n equals -1, you get that one. N equals 1, we get this one. N equals 2 spins, we get that one, and so on. And that's all of the angles that are coterminal with this one. And of course, what's the big whoop about this is that the sine of any of these angles, or the cos of any of these angles, or the tan of any of these angles, well, they give you the same trig ratios, which means that when we're solving trig equations, it gives us lots and lots of answers. Okay, on to the lesson. Solving linear trig equations 2, which implies there was a linear trig equations 1, and that was way back in the last chapter. And you've also done these in grade 11. So this, as we'll see, will get going fairly quickly into new stuff. This first one is review. Review of grade 11, review of what we've already done in our course. Remember, the rest-all technique for solving any trig equation like this is 3 steps. Diagram, calculator, and then think about the other solutions, right? And notice it just wants the principal solutions, the solutions between 0 and 360, 2 pi. And so diagram, what do we mean for a diagram? Usually, depending on what this answer is, usually it's some sort of unit circle deal, right? So here's my unit circle. This is the way that we thought about this before. And then we think of, Well, which quadrants could the sign be positive? Well, here and here. And in fact, one of the techniques we thought about is this is the y coordinate. Y goes with sine. And when is the sine square root of 3 over 2? If this is the unit circle, square root of 3 over 2, you could pound that into a calculator, is about 0.86. Right about there, right? That's a y coordinate of about 0.86. And so that actually gives me my two terminal arms. I have one in the first quadrant, the sign is positive, and I have one in the second quadrant, the sign is positive. That's my diagram. There are my two solutions. Let me just write them on there. So this is kind of like my x1, and this is kind of like my x2 here, my second solution between 0 and 2 pi. So there's my diagram, and notice I could use my calculator, but the bells should be going off in your head. This is a perfect ratio. This is one of our good angles. So I'm going to say calculator or chart, right? Some people don't use the chart. Some people think of, well, this is a pi over 3 angle, right? This is the square root of 3 and 2 and 1. They remember the triangles, and so they remember this way. Either way, I know that from the chart or from here, my related acute angle is pi over 3, right? And that's kind of this. That would give me, the pi over 3 would give me my first angle. In fact, x1, my first solution, x1 is pi over 3, right? But notice, if I wanted all solutions, then it could be pi over 3 plus any number of spins. So just for funsies, I'm going to write in the bonus learning for the day, which is all the rest of the solutions, which is plus 2 pi n. N is any real number. This is all solutions in green. All solutions, not just these ones, right? Okay, well, what's the other solution? The x2 here. Well, remember, I said that this raw was pi over 3, right? So this thing's pi over 3 here as well. My diagram's getting crowded, but this is pi over 3. So my x2 then is pi, half a turn, subtract pi over 3. And some of you can do that in your head, and that's dandy if you can do that in your head. But I'm going to get common denominator, subtract this, get this angle. It's 2 pi over 3. Yeah, I maybe should have been able to do that in my head. And notice, just for funsies, I could write all the solutions, plus 2 pi n, again, where n is a member of real numbers. So not only do we have two solutions to this equation, there are an infinite number of solutions that are coterminal with x1, and there are an infinite number of solutions that are coterminal with x2. So if I wanted to state the whole solution set, it would be all of these, plus 2 pi n, and 2 pi over 3 plus 2 pi n. N is just a real number, or a integer number rather. But if I wanted to stick with the principal solutions, like I was asked that, I realize that. The principal solutions between 0 and 2 pi are just the normal ones that we got. All right, dandy. This is review. Oh, the green stuff is new, maybe. Okay, the green stuff was new. The rest was review. So second one, some weirdness. Now things are new, and there's a bunch of stuff going on. It looks like the equation, not the function, but the equation has been transformed. And I think we'll pick this up in video 2.